personal video of Burton, so I can fly around his drone to give you an idea of what we're going to be talking about. Now, if you want to talk a little bit about this video as well.
Yeah, so this is a little micro quadcopter. We'll talk a little bit about sizes and types, but basically this thing's only 65 millimeters from motor to motor. It's really tiny. That's my dirty front yard I'm zipping around. These are really cool for close proximity flying. I like them because you could really get into tight gaps and things like that and set up cool little courses that you could zip around.
And Burton's also wearing goggles, and this is the live feed that he sees in the goggles as he's flying.
Correct. There's typically a couple different ways you can fly. There's what they call line of sight, which is without goggles, where you're just basically seeing the quad as you're flying it. And that gets a little tough because your orientation can get out of whack when, for example, if the thing is coming, if you're flying away from you, it makes sense to turn left or turn right. But as soon as you flip around and start flying towards you, it becomes weird. Whereas with FPV goggles, it feels a little bit more natural, like more like a video game, like you're actually behind the wheel, so to speak.
So today we're going to talk about everything that goes into flying this drone, all the components, everything you have to do to build it, and that's how we're going to jump around about drones.
So I'm sure people have heard all these different terms: drones, UAVs, quadcopters, multi-rotors. So what's the correct term to use? There are actually really no difference between any of them, but in the hobby we like to call them quadcopters because in the last couple of years there's quite a bit of a stigma around the word drones. When I hear drone, I think of like spy operations or something military, and a lot of the times you just bring up the word drone and people will get kind of nervous. So we tend to call them quadcopters. Anything with more than 4 motors too, people tend to call multi-rotors. There are hobbyists out there that are building some pretty giant aircraft that have like 8 rotors. Sometimes you'll hear the word octocopter or things like that.
So first, just want to talk about the types of drones that you can have. There's aerial photography, like your DJI Phantom drones. Those are usually slow, stable flights. They're used for movies, commercials, hobby. You go to a nature preserve, you really like the scenery, you'll go about 1,000 feet up with this Phantom. You'll have a really nice camera on it, and you'll be taking long range photos with it. Usually flights last like 15-20 minutes on charge. And then there's racing hobby drones, and that's kind of pictured in the second one with the green propellers on it. This is for fast speeds. It's anywhere from 40 to 90 miles an hour. It has a lot less battery life, usually 2 to 3 minutes, because you're forced to speed so much. These are usually small compared to the cartridge drones. And then there's also toy drones, which is on the bottom. It's usually very small. It's very slow, like 15-20 miles an hour. Usually when you go to like a Walmart or Target, you'll see like a toy drone there. For today, though, we're going to focus more on like the racing hobby drone, how to build them, the pieces that go into it. I brought in one of the first ones that I built. It's a 250 size is what it's called. I'm going to pass this around too if you want to take a look. Everything that goes into it is very wiry. Yeah, we'll just kind of go into that. So speaking of all the types of drones, they have sizes as well, and that size is measured from one motor's its opposite motor, and then you call that a millimeter. So the drone that's being touched right now is considered a 250 millimeter, and you divide those into classes. So like a 450 class, usually your aerial photography drone is usually the 450 millimeter motor-to-motor size and up. 250 class is usually 250 millimeter down to about like 1 and that's usually where the racing drones you see on TV fall into. And then the 150 class, which is just 150 millimeter and smaller, are still some racing drones, but mostly like toy drones, and usually unclassified. And then the frame, so you've got your type, your size, and then you've got your frame. And a frame comes into popular layouts, an H configuration, an X configuration, or a stretched configuration. And that's all made up by material like either carbon fiber, plastic, or polycarbonate. You'll see racing drones usually do carbon fiber because it's going to be more durable, because you're going about 90 miles an hour and you're going to crash almost. And so carbon fiber is more durable in these crashes. Aerial photography drones are usually plastic because you're not going to be crashing as much. You're going to be going a lot slower and stable in your flight. There's assisted landing with your drone, so you don't have to be worried about breaking your drone as much. And then the small, like 150 class and smaller than that, usually is polycarbonate, very cheap. And you can kind of see like examples. There's some polycarbonate on the far left, There's some mixtures of carbon fiber and plastic on the right.
I think these are considered, like this polycarbonate here is, I think, a 120 millimeters, so it's considered kind of a micro drone. We'll get into different types of motors and stuff later on, but typically these smaller ones use brushed motors. So they're small, a lot smaller, and they actually have physical parts that are moving within there, so they tend to break down a little bit faster than brushless motors.
And with the whole configuration of the layout, the H here, as you can see, makes an H. The X makes an H. There's a stretched X where it's not a perfect X, and then there's a box size as well. Usually that configuration has to do with the weight and how it can handle its thrust. So like H frame will kind of go lean forward when it's flying, and it gets a little more air resistance, so they came up with X frame, which can cut more of the air and go more almost like straight up and down.
Yeah, a lot of the X frames, a lot of people that are doing kind of freestyle flying, not necessarily racing, are using X frames just because they're a lot more nimble. They turn a lot quicker. There's, when you start to get into the hobby, there's some necessities, obviously, and a radio transmitter is one of the first things that you're going to need if you want to get into the hobby. A lot of toy grade quads will come with their own little radio, and a lot of the times those are really, there's not any other quads you can fly them with because they're pretty much bound to that toy. But your radio transmitter is the device that actually lets you control the craft. Signals from your radio get sent to the receiver on the quadcopter, which then translates your motions into commands that the quad can then, yeah. There's a couple main things you really need to know about radio transmitter. There's channels. So when you're deciding what type of radio to get, it really depends on how many different things you're going to want to control. There's 4 main channels on every radio that represent the movements of the sticks. So like, for example, throttle could be channel 1, yaw, which is your left and right motion, could be channel 2, and then roll, for example, would be channel 3, and pitch could be channel 4. Some of the other things you might want to assign on a radio would be like to arm your quadcopter. Usually it's not armed when you first fire it up, and then you could assign a switch to actually arm the quad. Some other things that people are using channels for are like a buzzer. For example, if you're flying FPV and you've gotten like a couple hundred feet away and you crash, which tends to happen quite a bit, it's hard to tell sometimes where you've actually crashed. So a lot of people will put a buzzer on their quad and then be able to arm it through here, and they'll make an audible buzz so you can find it.
A lot of people put LED lights all over their drones as well. Then you can actually control them with the channels as well. So if you want to fly at night, flip on LEDs.
Yep.
How do you assign different channels to different types of motion?
So there's, that's another thing too, is there's all different types of radios. And one of the big things to decide when you're getting into the hobby is how much money you want to spend. But, this is, I think, in my opinion, this is the biggest and best investment you can make. I also have the same radio. These are kind of middle of the line, I'd say. I think they're about $225 nowadays, but there's 16 channels that you can individually address on here. And the firmware for this thing is open source. You can pretty much program this radio to do whatever the heck you want. It's pretty easy to go through and assign different channels to whatever you want.
Yeah, what channels does it control?
It pass this around too, if you guys want to take a look.
Right. Okay.
And also with radios, there's different modes. There's 4 different modes that determine what the stick layout is. Typically in the United States, every one of the radios is on mode 2, where your throttle is on the left-hand side, and then you've got your yaw, your rudder, and then elevator, which is your pitch, and the aileron, which is your roll. In the UK, a lot of the radios are on mode 1. It's kind of, think about it like kind of driving on the other side of the road. Those are all configurable too, usually through the more expensive radios. Some radios though, on the cheaper end, you have to look for whether it's mode 1 or mode 2 because you wouldn't be able to change it. Another thing with radios is the protocols. There's all different types of protocols that work with different receivers. So what I was told early on when I first got in the hobby too was decide on what radio you want first. Look for your radio first, what kind of features you want, how many channels you're going to want assigned. If you really like to go custom with things, get something that's firmware, that you can upgrade. And then from that point, you'll know what protocols are available for that radio. And then from that point going forward, you can decide what kind of radio receiver you're going to want to get. And a lot of them aren't compatible with each other, which is one thing. So there's that radio is called the Taranis. So there's usually only receivers that are compatible with Taranis's protocol will work. The receiver basically takes the signals from your transmitter and then processes them to send to the flight controller. Like I said before, it's best to land on the type of transmitter you want first, and then you can research. There's tons of different receivers that'll work with individual radios.
Yeah, it's actually, you'd think it's a really simple thing to choose just a radio and a receiver, but I mean, the protocols alone just make it so intense, and there's just so much information out there.
Yeah, I mean, we could talk for like 3 hours just about radio protocol.
But I mean, I would say S-Bus and the PWM are really the most common.
Yep, the most popular.
So that's like it's just when you buy a drone and you end up buying something like a Taranis, you're going to have to configure it to work with your receiver, and then you're going to realize, oh, I don't know if my receiver is S-Bus or PWM. And that's where you start getting into everything about protocols. But that's why, like Brendan said, you do your research up front before you buy your controller, because then you know what kind of receiver you're going to buy with which protocol supports. Because you end up buying twice sometimes in this hobby because you don't know up front what to do.
Yep. Some of the smaller ones, like the footage we saw at the beginning, the flight controller that is on that quad actually has a built-in receiver. So sometimes you'll have to look for, when you're looking at smaller flight controllers to purchase, you'll have to look at what kind of integrated receiver you'll have. Which brings us to flight controllers. Flight controller, very simple, is the brain of your aircraft. It takes all the commands from the receiver and then processes everything to run the motors. Most flight controllers have the basic sensors you would need. There's like a gyroscope to keep the quad level, an accelerometer. Some more advanced flight controllers will have like a barometer on there, as well as a magnetometer, a compass. Some of the aerial photography drones you see out of the box, their flight controllers have barometer and the magnetometer. With the barometer, you can start to do things like altitude hold, so it'll actually determine at what height you want to stay. That's why some of these aerial photography kind of out of the box drones that you can get will have what they call like a return to home feature. Some of them have GPS built into them where you can just flip a button and it'll come back to you automatically.
And the one thing with the flight controllers too is like the whole evolution of them. This entire hobby started as kind of like a hodgepodge of components creating something that can fly. So the first flight controller wasn't even a 32-bit processor, really. It was a 16-bit processor. It had a really hard time kind of receiving input and having a feedback from that input. And so you couldn't actually turn the sharp, you couldn't do as many, I don't know, like loops and things like that, like stunts. And so in the past 3 years, it's gone from a 16-bit flight controller to a 32-bit flight controller to now a 64-bit flight controller. And all the firmware for these flight controllers are completely open source. It's all written in C, and you can go on GitHub, you can get that code, you can fork it. A lot of popular flight controllers happened because someone forked one of the firmware repos and then ended up making the code too efficient for the board. And so they ended up saying, well, now we need like a 64-bit board. And so then someone came out and made a 64-bit board, and the code became more efficient, and it just keeps on iterating like this, which is actually honestly really cool.
Yeah, and like with any of these other components, flight controllers is a huge topic. I mean, we could go for hours on all the different flight controllers and things that you can do with them. We've got the link there with some more information too. ESCs are what actually get the data to your motors. So your receiver will pick up commands from your transmitter, and that receiver sends those commands to the flight controller. The flight controller then sends signals to the ESCs, which will determine which motor to actually power. For the smaller quads that have brushed motors, you typically don't have ESCs. They're usually built into the flight controller because there's less power that really needs to go to them, and it can all be integrated on the board. One of the big things with electronic speed controllers that you want to research when you're putting together a quad is how much draw your motors are going to take. So quadcopters can pull a lot of power. So you want your ESCs to be able to handle the load that your motors are drawing at any given time. The racing quad I have, the 210, has 30 amp ESCs. Yeah. So I mean, at full power, these things are pulling a lot of amps.
And as flight controllers get better, and as battery capacity gets better, 30 amps not good enough. In like 2 or 3 years, you're gonna end up not being able to draw enough power, and you're gonna burn out your motors. Because yeah, I think 2 years ago 20 amp was all you needed.
Yeah.
And now the past year or so, 30 amps is what you need. It just seems to get bigger and bigger.
On my 210, they're 30 amp ESCs, and the battery is 75C. Like the burst rate is just it's crazy.
The drone that was Vestron was built a year and a half ago, and that's 12 amp ESCs, which was totally normal for a drone then, and now it can't handle the batteries today or the flight controllers today. And then, so talking about motors, I have built another racing drone, but it crashed and got obliterated. So I have the skeleton left of it. But as Burton was talking about, like you can see the ESCs leading into the motors. And so we're going to talk about the motors in a second. There's also the power distribution board. So this kind of just regulates all the power that's going to go out to the ESC, the flight controller, and that all comes in from a battery lead. We'll talk about batteries soon as well. But these motors here are copper wire windings on the inside and magnets. And everyone knows magnets are very magical. So when these windings get energized, they create a magnetic field, which then spins the motor continuously, and then you get just continuous current coming in power, then you get thrust. And as Burton mentioned before, there's brushed motors and brushless. And just kind of some of the difference, brushed and brushless follow the same technique of a winding, creating a magnetic field, creating force to rotate the motor. But there's some differences that a winding, the copper wire, is on the rotor for a brushed engine, and then windings are on what's called stator for the brushless. And I've got a diagram to show what the stator is and what the rotor is and all that. But there's advantages for a brushed motor is that they can be power directed. Like Burton said, we don't need these ESCs here because it can take care of power, no problem. It's very cheap, it's very old. I think there's an argument that brushed RC motors have been around since 1870. And the brushless, or the disadvantages of using a brushed motor are that they are very inefficient. So there's lots of friction because you've got these copper wires on these rotors. So as the rotor is spinning, you've got interference from the windings being on them, and you'll lose some of your power. Then you have to add more energy into it to get more power. And it wears out easily because of the winding being on that rotor. So it'll continue to spin on, just wear out the winding on there. So brushless here, which is on pretty much every racing drone, is all brushless. The advantages are that it's very energy efficient because now you move those windings away from that rotor, so you actually spend less power spinning, and so you get more, or sorry, less energy to spin, so you get more power output. It's also very durable because you're not going to blow out your windings. And the disadvantage though is that it's a lot more expensive than a brush. And price, it's debatable. A brushed engine, like less than $10.
Yeah.
And a brushless is usually more than $30. So it's hard to really argue price with
There's a lot
that.
of innovation that's been happening with these motors too, so and they just keep getting cheaper and smaller and lighter and faster.
And so, like I said, here's kind of a little diagram to show what's going on in this brushless motor. So the stator, as you can see, with the magnets on it, with the windings on the inside, that's the copper wire in there, and then it's lined with the magnets along the motor belt. So this is the motor belt on the inside, or sorry, on the outside. So that's just that's how it's gonna spin. So there's a motor size, and on the motor size, they show a 4-digit number that lets you know what the stator width is and what the stator height is. And the more height you have, the more power you have, the more width you have, the more torque you have. And that becomes very important for racing drones and photography drones. Photography drones will usually have more torque, and racing drones will usually have more power. So you'll have usually like a bigger engine, like it sounds like a bigger motor for a photography drone because you can have more payload, so you need more torque. But on racing drone, you can be as light as possible, so you don't need as much torque, so you can have much more power. So then also the shaft and the motor belt indicates propeller shaft size as well. And we'll get into the propellers and how they play into these motors. But then also, so the two big things are knowing really what the size of your motor and then the KV. The KV is that velocity constant, so that value is related to for every one volt, I will increase my RPM. And so most common like 250 quads have a 2300 kV motor, and then they've got a 3S battery. The 3S battery means it's going to output about 12.6 volts. At full throttle, that means it'll take 12.6 times 2300, which will only give you 28,000, pretty much 29,000 RPMs, which is a pretty quick quad. And then typically, when you have a higher KV, you've got smaller propellers because you're not going to have as many RPMs, and then lower KV means bigger props. And you'll have, so like a DJI Phantom is something like 1500s kV, and the racing drones are like 2300 to 2700 kV. And this year is a 2700 kV motor. And then after you figure out your KV and you figure out your motor size and propeller size, you also need to take into account the thrust of your motor. So taking just to figure out your thrust that you need, you have basically the weight of your quad, which typically is 200 to 500 grams. And so you want to be able to always output 2 times the thrust in weight of your actual quad. So the ratio is always 2 to 1. So for like an example, you've got a quad that weighs 1 kilogram. So each of your 4 motors should give out 500 grams of thrust equal to 2 kilograms. So you've got the 2 to 1 ratio. If you did not have this actual thrust, you wouldn't get your quad off the ground. Or if you did, it would go not even a foot off the ground. And then the more payload you have, typically you want to have a higher thrust ratio. So you'll see photography drones will be about 3 to 1, 4 to 1 thrust because you're going to have a nicer camera equipment on, maybe a gimbal or something. You're going to have a lot more weight on it. And then racing drones, you want it pretty high, like 6 to 1. Some of them get up to 8 or 9 to 1, and you get some very fast quads, I think like 110 miles an hour. And then on the right, it's kind of just a simple sizing chart. Like take a simple 2200 kV engine. You've got your voltage, you know what your current is, and your thrust, and power, and then you get an efficiency rating and your speed. Basically, when you're doing like a motor thrust, it's 2300 kV engine is good enough for a 250 size quad.
Yeah, I have a 210 that has 2600 kV motors on it, and with a 4S battery, and 30 amp ESCs in it. I mean, it's scary. It's a scary fly, isn't it?
Yeah, same with the one that blew up. It's very fast. So then, after you figure out the motor you want, the frame you want, you have to pick out a propeller, and a propeller size does matter. And each propeller has blades on it, and you have blade count. So on the right would just be called bi-propeller, just 2 blades, and then a tri-blade propeller with 3. The more blades, the more power you're going to draw underneath with the thrust. So just the propeller you choose really depends on the frame of the motor. Like I was saying before, that the shaft of the motor should tell you the kind of propeller that you need. So usually, and here's a chart here as well with the frame size and the prop size and motor size. So 210 to 250, you're going to see really 2204, which was the 22 for the stator height, and then the 04 for the stator width. And that tells you that I will have a propeller of probably 5 inches. I could do a 4-inch one, I could do a 6-inch one. And then I also see the KV rating, as you can see here, will tell me the kind of propeller that I want. But typically you'll see 210 to 250 quad's going to be 5 to 6 inches on a propeller. And then there's a size indicator with propellers. They'll usually have a number like 50-40. Then be careful wonder what that means. So 50 stands for 5 inches, and the 40 is the pitch. So you're going to have a 40-degree pitch angle on your propeller. The one thing to note is that the dangerous thing with propellers is that if you do not have an ESC that can handle the amperage of the power that a propeller draws on your engine, you can actually blow out your engines and your battery. So propeller that can generate more thrust, like a tri-blade or a quad blade, something that can't handle that kind of current being drawn out, will actually both puff up your battery and possibly blow it up and burn out your engine or your motors, and they will not work.
Yeah, so getting into FPV, there's when I first got into the hobby, I basically flew line of sight, and I really wanted to get into FPV right away, but I'm kind of glad I didn't, and actually researched a lot more first. There's tons of different equipment you can get out there. The goggles that you see in this slide are some of the top end kind of industry standards for some of the guys that are racing, but they're also $500 goggles. So to get into the hobby, I went with kind of a, introductory, I'll call it, level FPV. So you'll see really nice goggles like this, but I'm sure maybe you've seen too, the huge box model. It looks like a huge box on somebody's face when they're flying. Those are kind of the ones if you've seen me fly around the office, those are the kind I have, which are, just for getting into the hobby, it's perfect. But basically, FPV is a method for you to be able to see what the drone sees as you're flying it and fly in first person view. There's 4 main things that go along with the FPV system. Like your camera, obviously, which is on the drone. He's got one on there. Then there's the video transmitter, which if you look on this guy, it's the thing on the back that the antenna is coming off of. And then there's a video receiver. Typically, your goggles will have a receiver built in. That's another thing about these goggles that you see on the screen. Not only are they really expensive, it doesn't come with a receiver, so you got to buy the receiver separately. The ones I have has an integrated receiver, and then that's really it. There's a lot, again, with all these topics. We could go on and on for probably 2 hours about different transmitters, receivers, and different frequencies. But when it comes down to it, there's bands and channels that you can select on your receiver that a lot of guys when they're racing, a lot of people when they're racing, there's 8 to 10 quads out there. So you could select different bands and channels so that each pilot is on a different channel and there's no interference.
Yeah. Just to show, the FPV gear that I use is just a TV content. It's pretty small, but it was very cheap. But as Bert said, there's a video transmitter antenna here in like kind of cone shape, and it's got a matching antenna on the other end as well. So as this is flying, it's sending just a 2.4 gigahertz radio signal from here. This is receiving the 2.4 radio gigahertz signal in it. It's good for a really long mile. Yeah, like it's insane how good of a signal it gives. One thing is that flying around trees gives it lots of interference.
Speaking of interference, sometimes when you see 2 antennas like this, some goggles and monitors like this will have what they call diversity. So there are 2 different types of antennas. One's a long range antenna and one's more close range. And the receiver is actually smart enough to know, and if your close range antenna is not picking up enough, it'll switch to use a long range antenna. Those are typically more expensive receivers, but you're starting to see a lot of that now, especially in racing. And there's different, when there's quite a bit of interference. Another cool thing I've seen too is there's a group called MultiGP, which is one of the largest organizations now that's actually doing drone racing. Since all the different pilots that are on different channels, what I've seen people do is sit in the audience, and you'll be able to just flip through channels and see what all the other pilots are seeing while they're racing, which is pretty cool.
I've actually brought this to races, and then I can just flip through channels and I can find, if I know someone that's racing, I can find their feed and see what they see, which is really cool, honestly. And real quick too, with like the first person view, as cool as it is, it still has its limitations today in terms of technology. So it's obviously analog signal, you can't put a digital signal yet because of lag and latency, but a lot of this stuff, especially the FPV camera on here, these are really old security cameras, equivalent of like the 90s, and it's TDL, which is like TV line.
Yeah.
So you have very grainy footage. So I think as you saw in Burton's footage, that's straight from that camera. That's the actual quality that you get. And there's not a whole lot of big technology players in this space. So all they have to work with is existing components that they know of, and they'll, as cheap as they can get them, and throw them together. So like these goggles here are two 4:3 aspect ratio lenses, very, very low quality, maybe like I think 480 definition. And it's maybe one of the pain points of the hobby is that these goggles get very, very expensive and you don't get really any quality. And I think Burton had, or I can even say like this kind of monitor is maybe $50. These goggles here are maybe $500, and I get the same image quality, which is really crazy.
Those are, it's kind of crazy. Yeah. A lot of times, if you see really high definition footage of people flying around, they'll typically have a GoPro attached to there as well. So the video feed you'll be getting is from one of these, the TBL, or the TBL, or it's like a CCTV TV camera.
Yeah, and it's the same camera on the drones itself. It's like for this here, it is actually the same camera that's in like your reverse camera on your car. It's literally the same camera. And that's to show like that there's not as much innovation going on in how it's a hodgepodge of existing components, so that someone said, hey, I have this camera that I have on my car and I know it's pretty cheap. I could use that for my drone. And that's literally how FPV started. Someone just said, I have this camera, I can do this. And it has not changed since. People are still saying, I have this existing camera, let's just use it. So one problem, if you've ever seen like in your car, you back up and the sun is sitting behind you, you may not be able to see anything because the sun is just blocking out all of your vision. Same thing with drones. If you are flying and you get any kind of sunlight there, you get like a blackout and you can't see, which is a little dangerous as well.
Which makes me think of in the hobby, a lot of what they'll recommend is if you're flying FPV to always be with somebody else as a spotter. So you're not really aware of kind of what's right next to you or what's even in your close proximity because you're so immersed in what's happening in your goggles. It's really, for safety reasons, it's good to have a spotter with you.
And to just kind of jump on what Bert was saying earlier about like putting a GoPro on the camera, I put a GoPro session on this, and it's got a little dampener to kind of keep it stable when it's flying, and it's tilted up because it's usually going to fly in this direction. So you want to still be able to have the camera somewhat straight. But yeah, you just throw a GoPro on here, you start recording as soon as you start flying, and you get honestly really nice footage. And it's a really popular thing with the drones is having a GoPro or one of the GoPro clones that you can get cheap.
So batteries is another huge topic. We can talk for hours on batteries, but essentially what quads are using are LiPos. It's got the best discharge rates and the most capacity for really what kind of flying you're going to be doing. Since the ESCs can draw so much power, you need something with a really high discharge rate. There's 3 or 4 main specs you want to start researching or learning about when you start to research batteries. Is voltage, obviously, how much power, and then C rating is the discharge rate, and then obviously there's the capacity of the battery itself. Go ahead, you can go next. Yeah. So your voltage obviously is how much your battery will have at a full charge. A typical cell in a battery is 3.7 volts. You can wire cells in series to get a higher voltage. Cell counts. When you see that, when you see the specifications of a battery, you'll see things like 1S or 2S, 3S. Those are that denotes the cell count of the battery. So like a 4S LiPo is a stack of 4 3.7 volt cells. You get a total of 14.8 volts. Whereas a 1S LiPo would just be one cell. Your C rating is the rate at which your battery can be discharged. Since when you're flying these quads, there's a lot of bursts when you're racing. You want a really high C rating, which means that it will be able to discharge at a really high rate. Like I said, there's a ton of information on this stuff. We've left a couple links here, but the internet is great for things like this. There's tons of people that have really nice YouTube videos on battery performance with different, versus different motors versus different ESCs and what type of batteries you're going to want.
I would say also C rating. Typically people that are very, very energy conscious in a race and they want to make sure they're getting as much power as they can for as long as they can, they'll care about C rating. If I'm going to be taking my drones in my backyard, I don't care really about C rating. Yeah. And same with like the cell. 4-cell batteries can give you longer power for more time. but then a 3-cell battery or 3-ounce battery will be just fine as well in like a backyard. And some of these things that we get into, like the kV, the C rating, the cells, and the S rating, that's all nuanced on the high end. If you're racing and you're trying to, it's like racing a car and you want to lose weight in the car, so you rip out like the cup holder. It's the same thing with like a C rating on these batteries. It's going to give you a noticeable difference if you know what you're looking for, but if you don't know what you're looking for, you won't really notice the difference.
When you're first getting into the hobby, I think the capacity is probably more important. You're going to want to fly a little bit longer than yeah, I mean, it's always nice when you're first getting started to have to change batteries every 5 minutes.
Yeah.
Because they literally do burn out in like 3 or 4 minutes.
I think that's always the biggest disappointment when getting into drones is you think like, oh, I'll fly this thing for an hour or something, and then you realize, oh, it lasted 3 minutes. Well, this kind of sucks. But
You've got a bag of batteries. Like to be able to fly for an hour, you need like a bag of 30 batteries.
But there's some great resources online to tell you kind of like that sweet spot where you'll get maybe 5 minutes with your drone setup based on the capacity, the S rating, and the C rating, which then that's good to know. And then just real quick, some of the safety and dangers with drone flying. First is batteries. Batteries or LiPo batteries are very unstable if you are charging too much or overcharge them. If there's a broken cell that you don't know about in your battery, you could run into problems with that. So one of like the big safety things is to always get a fire retardant bag to place your LiPos into. And you really only run into problems when you're charging them. So when you charge, you want to keep it in a fire retardant bag because there are lots of videos of people that actually blowing up a LiPo from just barely overcharging it.
Yeah.
A lot of things that charge your batteries have safety mechanisms to cut off if they're at the maximum charge, but it's always better to be safe. And then FAA, apparently FCC, I just learned today, is a big deal with drones. You don't want to be within 5 miles of an airport. You don't want to be over 400 feet if you're near, maybe like right outside 5 miles of an airport. If you are going to be outside of 5 miles of an airport, maybe like 6 miles away, you want to call the airport and let them know. Police departments are taking this a lot more serious, as there's been a lot of complaints from local airports saying there are too many drones in their airspace. Privacy is also a big issue for people. They hear drone and they think that my privacy is compromised. They think there's a drone in the air videotaping me. And so you can get some sensitive people in your community where you're flying, thinking that you are invading their space, invading their privacy. So it's always nice to kind of be aware of your surroundings when you're flying. And insurance, there's a great RC group that offers insurance for you. You never know what can happen with your drone. You can cut out battery loss while it's flying. You don't know where it's going to land. And insurance has like a $250,000 comprehensive coverage for you. And you pay $75 a year for it. And it's really hard to argue not to get it because, again, you don't know what can happen when you're flying.
The FAA has rules around weight too. So like that's why you see when you see these racing drones, they're typically under 250 grams. I believe that's still the weight limit. Anything above 250 requires an FAA license now.
And your drone also has to have your FAA number on it. So it's just so they can bring it back to you or prosecute you, whatever you're doing with it. But when you're flying, you have to have that FAA number somewhere on the drone as well.
Yeah. And I just learned recently with the FCC, this is actually a requirement now, although I haven't really heard of it being enforced. But apparently with the FCC, with your flying FPV, you're supposed to have a ham radio operator's license because it deals with a different low frequency band. So they expect you to have this introductory ham license, which is pretty interesting. So I just picked up a ham radio book and I'm going to try to get the license for the heck of it because it seems pretty interesting.
Yeah, if you try to go to like a race or a meetup or something, they're very stiff on the insurance and the FAA, but I've never heard people checking for FCC, which is an interesting one as well. And then I just want to talk a little bit about the community as well. Just how pretty much all of the innovation comes from the community. There are like big companies in the space, but they're all start out because of the community. Someone is doing it in their free time, they're realizing that they can sell it or they can manufacture it or whatever. And so a lot of companies come because of the community, a lot of the innovation comes. People build their own FPV goggles and then they share the instruction set online and they say, like, here's the part that you use to build it on Amazon and go build it for $10. And it's actually awesome. It's got a very open source feel to it. A lot of the software itself is free open source software. like we talked earlier about flight controller software. I mean,
Pretty much every flight controller is configurable too. They'll have a USB jack or some other mechanism to hook it up to your computer. You can flash the firmware yourself once you've learned, and then there's also, people have created Chrome extensions to be able to configure your quad. You just plug it in and you can actually configure each motor individually, you can configure all the different settings, things like that.
Thank you.
Yeah. I can't say enough about the community. It's just amazing. Really, I've learned everything I know through the open source community around quadcopters.
And then we just provided a lot of links of where to get information, where to buy, good places to see videos.
This YouTube guy, Painless 360, he's some of the best videos out there, like instructional videos, anything from beginners to more advanced topics. He's great.
Yeah. I mean, I would really relate drone building to computer building. All the parts are there, you just have to go and put them together. The only thing is that there is some soldering, but we're hoping that after this presentation, you get an idea of how you can build a drone.
Yep, so we were thinking, this is part one, we were thinking of part two, where we actually build something, do like a small micro build that doesn't require much soldering, and kind of go over some more of the components. And then if there's enough interest, I was thinking of doing some more advanced brown bags too, to get kind of a deeper dive into flight controllers and things like that.
So if there's even more interest, maybe we do a drone racing league in the office with micro drones. Yeah. Any questions?
Yeah.
Do you guys race, and where did races occur?
So I'm a member of Multi-GP. I just became a member a couple months ago. I haven't really gone to any races yet, but there are races all over the place, and they do a lot of practices in Schaumburg. There's some people that actually rent out. Have you seen those big, like dome, like bubble-looking dome, like soccer fields?
Yeah, for like
Yeah, a lot of people are renting those out for indoor practice or races. Yeah, Multi-GP is probably the most popular racing group out there now.
Yeah, I've been to one multi-GP race, and it's incredibly well organized. There's a national GP organizer that they have chapters in every state, in like every city, and they're responsible for kind of creating these events to get GP points. And if you qualify with enough points, you go to the national GP event.
Yeah.
And there's prize money in it.
Yeah, there's people walking away with like 50 grand.
Are they circuit races or is it just like straight narrows?
No, there's some pretty intense races. Yeah, there's.
It's the famous one, yes.
You know what? Maybe just check out Multi-GP. Yeah. GP YouTube there.
Oh, yeah, makes sense. But yeah, usually it's obstacles set up. We gotta dodge the obstacles, and the race format is that it's how many laps you can compete in 2 minutes. So people will be going, hopefully this has good footage and not just a pan. So a race course really can have anything set up. You try to make obstacles that you have to go around for the race. And yeah, like I said, it's just a 2-minute race. And every time you pass the start line, you collect a lap. And it's, I'd say there's 10 heats or 10 races you go into, and it's at that end of those 10 races, it's how many laps you got, and that's the place you get. Some people are just insanely fast too. People are going like 100 miles an hour. They still have precision in their quad. You can see they really make race courses out of anything. A lot of people will just put trees, or they'll put a cone around a tree and say, like go on the outside of the tree, and that's your course.
So they're competing individually. It's not like all drones flying around at once.
4 drones at a time
Oh,
is what they try to limit it to. So they have heats spread out as well. So they'll go through every heat for one of the 2-minute laps, and then we'll repeat about 5 or 10 times. But yeah, because of the radio frequency interference, it's about 4 people you want to have. And they've also, there's a whole debate about how much the megawatts that come out of receiver, or sorry, transmitter on your video. So like this drone here gives off 500 megawatts for its antenna, and it can actually bleed into other people's antennas, no matter if they're on a different band or not. And so as of maybe 6 months ago or 8 months ago, they banned all 500 megawatt drones from racing. So this cannot race anymore.
Yeah, the smaller ones that I like the footage at the beginning, that's only a 25 milliwatt.
And that's actually where people want to go. If they limit it to 250 milliwatt and they still saw bleeding happening, and they want to limit it to 25, which is kind of crazy.
Yeah, which also limits your range. The higher.
But yeah, the MultiGP here, this is the national organization, and lots of people open up their own charters to do it.
There's a lot better footage out there
Yeah.
somewhere. It isn't really. There's people doing indoor racing too. Like you'll see a lot of footage of parking garages. So I think it's a cool spot to do indoor racing.
I'm gonna say this is probably the most popular video.
Didn't ESPN do something with the drone racing league?
They did.
On like,
picked it up.
like warehouses or?
Yeah, last summer, ESPN2 broadcasted, I think it was actually the MultiGP final for the national.
I thought they were doing like 4-person heats and then at the end they did like 6-person.
Yeah,
Which is kind of insane.
yeah. And when they make creative courses like that,
Yeah.
it's just awesome. But yeah, the only problem right now with drone racing and being televised is that it's hard to find a format that works, because if you show people the actual camera footage that you're seeing from your TV, it's going to really turn people off because it's so grainy. And so they have a really hard time actually finding like the kind of soft spot for it.
A lot of them are going so fast too.
Yeah.
It's hard to like get footage of the whole pack, like you would like maybe in a NASCAR race or something. So it's kind of a weird format. I've been doing it for about a year and I'm absolutely addicted. Like, it's so much fun.
Can you fly like that?
Oh yeah. I'm not quite as good as some of the, I mean, there's.
It won't be as fast as people.
Yeah, exactly. The 210 that I built it over the winter, and I've only flown it once. It screams. I mean, it's scary how fast it is. And some of these guys, I think I just need to get more practice with going that fast, and then I could probably participate in races.
And they have novice classes as well for like first time racers. So they split up to 3 kinds of events now. I believe there's a pro, amateur, and a novice. And the novice one is perfect for people that first time doing a race, they can take their time. They don't. I mean, they still collect laps and give out prizes, but there's no pressure really. And everyone's usually around the same level. And a big thing with drones too is that one thing we didn't mention with the flight controllers is that there's some modes on them. So like an aerial photography drone is going to always self-stabilize. So if you go and turn it, as soon as you let go of the sticks, it's going to self-stabilize again. And then these racing drones, though, you turn off the self-stabilization.
And so they basically turn off the gyroscope.
Yeah, and it's considered acro mode. And so when you put the sticks to the left and it starts turning, and you take the sticks off, it does not stop turning. And you have to go manually turn it back. And so when it gets, and that's another really hard thing to get used to, is that if you start with drones, I always suggest like a toy, do line of sight, it's always going to be in this, it's called horizontal mode when it self-stabilizes. You get used to flying it that way, and then you turn it into acro mode, and that's a whole totally different feeling.
They have an in-between mode too. It's called Horizon. So, and you can adjust the settings for Horizon mode, but basically it's gyroscope up until like the last 30% of your sticks, and then it'll go acro. So I tend to fly in Horizon because it's great for making like really tight turns, but you also still get stabilization.
And when you want to do like tricks, so if you want to flip the drone,
Barrel rolls.
Yeah.
That's typically in full acro mode.
yeah, because the stabilization will actually stop it from going full over. It'll restabilize. Now this was like a really popular race 2 years ago.
Dubai.
Yeah, but it was $1 million purse to win, and I think 16-year-old, it was like $150,000. It's crazy.
So what, like, how in the warehouse course that we just watched, right? Like, how fast are they going in like a confined space like that?
Yeah, 40 or 50.
Really?
Yeah, and then in the more open space like that, there's probably like 80 miles an hour, especially on these straightaways like that.
So at what point, like, does the speed and the range affect each other, right? Like, do you have to actually be conscientious of like it's going fast enough that it can just pop out of range like that?
Yeah.
Or
Mm-hmm.
okay.
And another thing we didn't mention too is that on a lot of these receivers, it depends on what brand it is and a lot of other things, but a lot of them will have telemetry. So it'll actually the receiver can spit telemetry data back to your radio. So, for example, they'll use it for range. If you're getting within, kind of a danger zone where you're going to lose it, you can have it send you that information back with like an audible beep or some other kind of maybe haptic feedback.
Sure.
But there's a lot of the telemetry has gotten pretty awesome too. You can get range feedback, you can get your battery feedback. Alongside that too, they have the video transmitters. Some of them have built-in OSDs, on-screen display. You could also get other modules that you could, solder up to the board to your flight controller. But basically, it'll send telemetry data back to your goggles as well, so you can see like an on-screen display of all kinds of any kind of data you can think of really.
Yeah, great thing with the on-screen displays that as it's sending back the video footage through the antenna, it's giving you the
Parallels.
It'll never go wrong. But yeah, when you're actually like got your goggles on or through the monitor, it's going to give you battery percentage. It's going to give you elevation. It can give you. Usually those are the two most common.
Yeah. There's some that have the actual like horizon lines like you would see in the actual cockpit, things like that, like all kinds of cool stuff.
And because you mentioned kind of soldering other things onto the drone that aren't really typical, just to show off how cool of the open source community is. Some people in the Illinois area are working on putting sensors on the drones and lasers, and then doing like laser tag in the sky with the drone.
Oh, cool.
And so if it senses that you're getting hit by the laser, it'll shut down the drone or drop, and then you're off. A lot of people are working on stuff like that. People like shoot discs on them. That's cool stuff.
Yeah.
That's a good song.
Yeah.
Any other questions?
Cool. Thanks, guys.
Yeah, absolutely.